Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilation representations. This is standard 8.3c in the great state of Texas, and we are using item number 5 off the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a strange problem here. We need to graph something and there's no graph. They don't give you any visual representation here. We have triangle MNP and it's graphed on a coordinate grid, and they even give you the vertices, right? You've got M, you've got N, you've got P, and it's dilated by a scale factor of U, so they're not going to give you a number there. The scale factor is just a variable. The origin is the center, and you're going to create this M prime, N prime, P prime. So which ordered pair best represents the coordinates of the vertex P prime? Well, it's a lot to read without a visual representation. So let's see if we can at least put some type of graph on here. And we're not going to actually draw the actual tick marks. Let's just at least try to get them in the right spots, right? So our origin right there is the center. So M is going to be -3, -6. So I'll call -3 something like that, -6 like down here. So I'm going to put M right here. And then N that's pretty easy. That's 0 and then 3. So it's going to be like right around here. So I'll call this as my N. And then my P is going to be 6, -3. So over here and then maybe over here. So something along these lines right here. All right, so now we at least have a visual to look at. So if I were to draw this triangle, we've got the origin as the center, and we're going to dilate it. And we are going to dilate it by a scale factor of U. So that's the question. What happens with that U? And really specifically, we're looking at P prime. So we're looking at this P right here, which is 6, -3. What do we do with that? Well, let's look at our 4 options. So if we were to do a plus U right here for each of our coordinates, for our 6 and our -3, well, that's not going to dilate it. That's actually going to just slide it, or that's going to translate it. It's called a translation, or just a slide. Because really what we're going to do is we're just going to plus the U, assuming the U is a positive. We don't know what it is, right? That's just going to kind of make it shift up this way. It's not going to make it larger. It's not going to make it smaller. It's just going to kind of take the whole triangle and shift it over and up, since we're adding it to both the X and the Y. But that's not going to dilate it. Dilate is when we make it larger or smaller, kind of like your pupils on your eyes are dilating larger or smaller based on the light. So what happens if we were to divide by U? Well, we could divide by U, but that's actually going to have the inverse of what we're looking for, because a scale factor, check this out, that could make it smaller, obviously, but here's the problem. The larger the scale factor, the smaller it gets. So right, let's say my U equals 2, right? So 6 over 2 would equal 3. So I would shrink that from 6 down to 3. But what if my U equals 6? Well, now it's going to be 6 over 6. So that's 1. So the larger the scale factor, the smaller the result, because it's a denominator. And factor, we don't want to divide it, we're wanting to multiply it. So that's going to at least make it larger or smaller, but it's going to be the inverse of what we want. C is not really going to work because we're still just adding. We're just adding a little bit there. We're just going to end up sliding it that way, just like we did right there. So take a look. D is really what we're looking for. Scale factor, just look at that word factor. We just multiply U by each coordinate, the X and the Y, and we would get that 6 and that -3. So our answer here is going to be D.